Hello and welcome to Unit 1, Section 4, Composition of Functions, and we're going to have some class. Probably not fun, but class. We're just going to have some class, I'll put it that way. Now, composition of functions. So, suppose, how are we going to start this out? Suppose you want a cat, right? Like meow, like a cat, like a kitty cat, right? And you're like, well, how much is this cat going to cost? Because your mom's like, I don't want to spend a fortune on this dang cat. So you would say, well, I guess it would depend on how much food we feed it. And that would depend on how much the cat weighs, right? So we're going to say X. Oh, Lord. It's not how you spell cat. Catata. All right. X is the cat's weight. So then I have f of x is equal to the food eaten by a cat of x weight. Right? So f of x is going to tell me how much food my cat is eating. Well, c of, what are we going to call this? Y is equal to the cost of the food Y eaten by a cat. And that's the cost of the food. Well, so this food, Y, tells me how much food it's going to eat. So if I know that f of x is also equal to how much food it's going to eat, then I know that this is equal to the cost of the food eaten by a cat of x weight. And that's what this means. And a lot is the amount of food eaten by a cat of x weight, because cats can eat a lot. Sometimes they just lay down in front of the food bowl, so they don't even really have to bother getting up and doing anything. They could just go between sleeping and eating. And if any of you guys have cats, you know exactly what I'm talking about. They're either eating, sleeping, or knocking things off of countertops. So this would be a composition of function, or we've combined the functions. A good composition of function. So this you'll definitely see again. This is what the whole section's about. So it's going to be composition of functions. FCN. If you guys ever see FCN, that stands for function. You may see some of your math teachers abbreviate it like that. And SOLN equals solution. I don't know why. Honestly, it's just what we do. Okay, so you can, along with combining functions, composing functions inside of other functions, we can also do basic things. Like we can add functions. So if f of x is a function and g of x is a function, we can add them. We can subtract them. If f of x is a function and g of x is a function, we can subtract them. And we could subtract them in any order, it doesn't matter. You can multiply them. So you can say f of x times g of x, and that's what it will look like. You can also divide them, which would be fx divided by g of x. And you may think, hey, might there be a slightly easier way to write this? The correct answer is yes. there is maybe a slightly easier way to write it, depending on what you think of easier. So this is usually the preferred method of writing something like this, so that we only have to write x once. So it's your two functions are in the first parentheses, given whatever algebraic operation that is. And then this x on the outside, let me go. And then this one is f of g of x, and this one is f of g of x. So you will notice that these on the outside are the same thing. These are the exact same x's that we're talking about. Hopefully if this color coding helps you slightly. And then these guys are these guys. Oh, well, you include the operation, of course. And let's get, all right. So this is what combining functions using algebraic properties looks like. That's algebra. Okay, now let's see if we can do an example. There we go. Find and simplify the functions. Let's see if we can highlight that. Gonna have to find these guys. And we're gonna have to find these guys. Okay. So here, this is multiplication, right? So f times g of x equals, and that's how you'd say it, f times g of x is how you would say it, is equal to f of x times g of x, which is equal to f of x is x minus 1, and g of x is x squared minus 1. Now we're going to distribute. Suppose I could do this just as a quick reminder. Remember, first outer, so x times x squared is x3. You just add the exponents, right? xa times xb equals x of a plus b. That's the rule. Minus x. And then this inner one times this other inner one minus x squared plus 1. And that can be rewritten as x cubed minus x squared minus x plus 1. Now we want to find f minus g of x, which is equivalent to f of x minus g of x. So that's going to be x minus 1 is f of x minus x squared minus 1 is g of x. So we have x minus 1 minus x squared minus 1. So this first one, x minus 1, the f of x, since there's nothing in front of it, like a negative or a positive, we can just straight up drop those parentheses. X minus 1, and then we can distribute the negative. So x, this is a positive x squared, so that's minus x squared. This is a negative 1, so that turns into a positive 1. And that gives us negative x squared plus x, and these guys cancel, negative 1 and positive 1. And that would be our answer. Create a function by composition of functions. So what that means is we can create a brand new function. There we go. Let me call it h of x, and we're going to call that f of g of x. So f of x is a function and g of x is another function, and h of x is a composite. So it's the composition of f and g. And it's okay to not write the x in parentheses here when we're talking about this. There will be special restrictions on this domain since you do have a function inside of a function. This would be comparable to if you had the cost of running your air conditioner, right, on a given day. And then that day is going to depend on the temperature. So a function within a function is how we should think about it. So determining whether it is commutative. If you don't remember what commutativity means, I would suggest you Google it. It'll give you a much better definition, and you should kind of probably already know what it is. If you don't, that's totally fine. I'm not saying anything. Just Google it, because you can get a pretty good definition and some good videos of it. But it is outside of the scope of this class. So I'm just going to move on. Using the functions provided, we're going to find these two guys. Commutative, notice they've changed, right? We've just switched them to outside the parentheses. Which one comes first? Determine whether the composition of functions is commutative. There's that word again. That's a very important math word. Look it up. Okay, so we're going to find f of g of x, right? So what is, we're going to have g of x. We're going to have f. This is our f. This is our g of x. And what we are going to have is, so we're going to have f of g of x. And then that's going to give us f. And then you just literally you put g of x right in. So now I'm going to keep evaluating it. So I know that f is 2x plus 1. So everything in here replaces x. And this can get a little confusing when you have like long strings of things that have to replace x. So that means we're going to have 2. And then there's supposed to be an x, so I do multiplication by parentheses. So if I'm multiplying something, I'll put it in parentheses. That's usually my go-to notation. So my x is now what's in here, 3 minus x plus 1. Notice that this was x from our original f of x. So now that's going to give me 2 times 3 is 6 minus 2x plus 1, which is going to give me minus 2x plus 7. Now I am going to need g of f of x. And that's going to give me g f of x is 2x plus 1. Then that's going to give me 3 minus, and then instead of x, we're going to have the 2x plus 1. There we go. So that I'm now going to have 3 minus 2x minus 1. So we just had to distribute that. So that gives us negative 2x plus 2. So let's have a little look-see here. Let me undo that. These guys, are they equal? Absolutely not. They're absolutely not equal. So what does that tell us? That tells us that f of g of x, which is equal to f of g in the other notation, is not equal to g of f of x. So this is important. That's not usually the case. They're usually not equal. So composition of functions. When the output of one function is used as the input of another, that entire thing is called the composition of functions. So this is the formal definition. I mean, as formal as you guys are going to get of composition of functions. So here is an important concept. They're talking about domains and ranges. So the domain of the composite function is all x, such that x is in the domain of g, and g of x is in the domain of f. So there will have to be some exclusions we have to make. May exclude some x in the domain of g of x. So it's a multi-step process to find the domain here. And I just want to make sure that's clear because we'll have to find the domain. So the function CS gives the number of calories burned completing S sit-ups, and ST gives the number of sit-ups a person can complete in T minutes. It wants us to interpret C S3. So S3 means, remember it was S of T, is T equal to 3. So ST gives the number of sit-ups a person can complete in T minutes. So this is the number of sit-ups that can be completed. In 3 minutes. So then what does C of this big chunk mean? Well, if C of whatever S is gives the number of calories burned completing that many sit-ups, then this is the number of calories burned by doing sit-ups for 3 minutes. And I don't know, like, if any of y'all are big on working out. I'm certainly not. Whatever. 3 minutes is a long time to do sit-ups. I'm sorry. Yeah, call me weak or whatever, but 3 minutes is a long time in my opinion. So this is the interpretation of composite functions. So now we're going to investigate the order. F of x gives miles that can be driven in x hours. G of y gives the gallons of gas used in driving y miles. Which expression is meaningful? So f of g of y is equal to, so what is g of y? G of y is the gallons of gas used in driving y miles. And f of x gives the miles that can be driven in x hours. So g of y gives us gallons of gas, right? But for f of x, our x needs to be in hours. Well, how do we convert from gallons of gas to hours? I just thought you is ridiculous. I really don't think you could. So let's check out what g of f of x means. Let's see if this makes any more sense before we delve deeper down the rabbit hole of turning hours into gallons of gasoline. So if f of x here is miles that can be driven in x hours, so that's miles in x hours. And g of y gives the gallons of gas used in driving y miles. Well, notice that f of x is given to you in miles, and they want y in miles. Right? G of y, this inner function, has to be in miles. So this means the gallons of gas used in driving x hours. All right, see, that was so much easier than turning hours into gallons of gasoline or gallons of gasoline into hours. And so that's what I would go with. This is the more logical interpretation. All right, here's a good one. The gravitational force on a planet a distance r from the sun is given by the function g of r. Okay. So here we go. Not perfect, of course. There would be other colors usually involved in the sun, not just yellow. Actually, it'd probably be so blinding it'd be white. But our paper's white. So now we have the sun, right? Because the gravitational force on a planet a distance r from the sun is given by the function gr. Now, what should be our planet? I don't know. I kind of am partial to the color purple. So we're going to have this planet. This is our planet. And that planet, I don't know, we'll have an ocean somewhere. Something or other. All these land masses. There we go. Kind of like Earth. Deep, 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 deep ocean. Wonderful, awesome, super cool planet. So this distance, r. Here we go, distance r from the sun. So I'm going to draw these little lines here. If any of you have taken physics, I'm just going to use these to represent the force that is, it's pulling, the gravitational force. GR. And that's gravitational force. The acceleration of a planet, now we're on sentence 2, the acceleration of a planet subjected to any force. Guess what? We have a force, gravitational force. So the acceleration subjected using any force is given by the function a capital F. So a capital F is acceleration due to force. Well, our force is going to be g of r. So we're going to let g of r equal some force. Now this is the acceleration due to the force of gravity. And that would be what that means.